A supermarket warehouse on the outskirts of a large city begins its workday long before the store opens. Trucks arrive one after another, reversing toward loading bays, where pallets are unloaded and sorted. Workers move quickly through the aisles, with handheld scanners, checking incoming goods against digital inventories. Each box carries a small printed pattern of vertical lines and numbers. No one pauses to look closely at it. The workers simply pass the scanner across the label, and the system immediately recognizes the product, its supplier, and its destination within the distribution network. In this environment, the barcode is not a tool used by individuals in isolation. It is part of a coordinated infrastructure that connects manufacturers, warehouses, transport companies, and retail stores. The pattern of lines printed on a package functions as an identifier within a shared system. Without that shared system, the lines themselves would carry no practical meaning. Their role becomes visible only when thousands of items move through standardized procedures that rely on them. Before barcodes became common, large retailers faced a persistent logistical challenge. As retail chains expanded in the mid-20th century, the number of products handled by each store increased dramatically. Inventory tracking, pricing, and restocking were managed primarily through manual systems. Clerks recorded stock levels by hand, and cashiers entered prices manually at the register. Each product required human attention at multiple points in the process. This method worked when stores carried a limited range of goods. But as supermarkets grew larger and product variety expanded, the process became increasingly inefficient. Recording errors accumulated, inventory data lagged behind real conditions, and checkout lines slowed as staff entered prices manually. Retailers began searching for a way to automate product identification across their entire network. The problem was not simply technical, it was institutional. For an automated system to function, every product had to be identifiable by machines in the same way, regardless of who manufactured it or where it was sold. That requirement meant creating a shared identification standard that could be recognized across the entire retail industry. During the early 1970s, major retailers and manufacturers began collaborating through industry organizations to design such a system. The goal was to establish a universal product code that could uniquely identify items within a large commercial network. Instead of relying on store-specific codes or handwritten labels, every product would carry a standardized numeric identifier. To make this identifier readable by machines, the number needed to be represented in a format that scanners could interpret quickly and reliably. Engineers developed the familiar pattern of vertical bars and spaces, arranged so that optical scanners could detect the encoded numbers. Even if the label was slightly misaligned or partially obscured, the design prioritized reliability within busy retail environments. Products moved quickly across checkout counters, often at different angles or under varying lighting conditions. The barcode pattern therefore had to remain readable even when scanned rapidly. The spacing of bars, the structure of the encoding, and the inclusion of verification digits were all designed to ensure that scanners could confirm the accuracy of the data they captured. But designing the code itself was only the first step. For the system to function, every participant in the retail supply chain needed to adopt the same standard. Manufacturers had to print the codes on packaging. Retailers had to install scanners at checkout counters. Distribution centers had to integrate barcode data into inventory management systems. This required coordinated adoption across an entire industry. Organizations responsible for retail standards developed procedures for assigning product identifiers and maintaining centralized registries. Each manufacturer received a company prefix, which became part of every barcode printed on its products. The remaining digits identified individual items within that company's catalog. Through this structure, each barcode became globally unique within the system. When a product moved from a manufacturer to a distributor and then to a retail store, the same identifier followed it through every stage. Inventory databases, logistics software, and point-of-sale systems all relied on that shared reference. The first widely recognized use of this system occurred in a supermarket checkout lane in the mid-1970s. A scanner read the barcode on a packaged product, and the register retrieved its price from a digital database. The process took only a moment, but it demonstrated something larger. A single product identifier could link physical goods to centralized information systems. As more retailers adopted the technology, the advantages became clear. Checkout speeds increased because cashiers no longer needed to enter prices manually. Pricing errors decreased because the system retrieved information directly from the database. Inventory tracking improved because every sale automatically updated stock levels. These improvements reinforced the value of the system, encouraging further adoption. Retail chains installed scanners across thousands of checkout lanes. Manufacturers began printing barcodes on nearly every packaged product. Distribution centers integrated scanning into their sorting and tracking processes. Over time, the barcode became less visible as a technological innovation and more like an expected feature of retail packaging. Its presence signaled compatibility with a standardized infrastructure. A product without a barcode required special handling, which disrupted automated processes. The stability of the system emerged from repeated use across millions of transactions each day. Every time a cashier scanned a product or a warehouse worker verified a shipment, the barcode functioned within the same procedures and databases. The system did not rely on individual interpretation. It relied on consistent recognition by machines. Because the identification standard remained stable, the infrastructure built around it could expand. Retail software, inventory systems, and logistics platforms all incorporated barcode data as a core element of their operations. Even as retail technology evolved, the underlying identifier continued to connect physical goods with digital records. The design also allowed for international expansion. Standardization organizations coordinated numbering systems across countries so that the same barcode could function within global supply chains. A product manufactured in one country could be scanned and recognized by retail systems in another without modification. Today, in distribution centers, supermarkets, and convenience stores, barcodes appear on nearly every package item. Workers and customers rarely think about the institutional agreements that made this possible, yet the small printed pattern represents decades of coordination between manufacturers, retailers, and standards organizations. The barcode continues to function because the procedures that support it remain stable. Product identifiers are assigned through established registries. Packaging guidelines ensure the codes remain readable. Retail systems still rely on the same fundamental principle. A standardized identifier linking physical goods to shared databases. In everyday retail environments, the barcode does not stand out. As a remarkable technology, it operates quietly within the background of transactions, inventory updates, and supply chain movements. Its continued presence reflects not only a successful technical design, but also the enduring stability of the institutional system that adopted it.